Welcome, ladies and gentlemen. This video is about how to express a periodic decimal number as a rational number. And we start by explaining this directly by an example. So x is equal 7.45189, where the 189 numbers digits are repeated. So we express this actually by this bar. So what does this mean? It's 7.45, 189, 189, 189, 189, and so on. So at some point I have to stop. And what we want to study in this video is how to express it as a rational number p over q. And the p and q are natural numbers. And there is one trick. First of all, you multiply with the number such that this point moves to the right after this periodic, so after these repeated digits. So in this case, we multiply by 10 to the power of 5. Why? Because this is 100,000 x, which is then the digit moves after the repeated digits, but for sure they go on here, so they never stop. And the second trick is you just multiply with 10 power 2, which is actually 100x. So you can write it as 745.189. Okay, so you see, you first need to move the decimal point after all the digits, and in the second case you move the decimal point before the repeated digits. And why does this help? This is kind of a surprise, because you subtract these two equations now. And what do you get here? If you subtract 100, it's 99,900 x is equal, and what do you see? You get rid of all these digits after the point. So we have no decimal number anymore. And if you do the subtraction, so 5 and 4 is 9. So here we always have zeros. We don't need to compute these. 5 and 4 is 9, 4 and 4 is 8, 7 and 4 is 11. So 1 left over, so 1 and 4 is 5, 0 and 4 is 4, and the 7 remains. Yeah. So we have found a rational number for this periodic decimal number. So this is the general principle, and I also will demonstrate two more examples, special cases, so to say, or very simple cases, which everyone knows. But the first one is a bit more tricky. I want to study what is x is equal 0.9999999, which means it is 0.9 where the digit 9 is repeated. So here it is already, the point is before the repeated digits. You just have to multiply it now by 10 to move the point after the repeated digits. So it's a simpler case than above. And then subtract. So we subtract these two equations, so we get here 9x is equal 9, right? So what does it mean? The x is equal 1. So 0.9 periodic means x is equal 1. It is the same as 1. Special case. So another example. What about 0.3 periodic? So 0.33333. So actually you can also derive it from 0.9 periodic, which is 1 divided by 3. So the result will be 1 over 3. But for demonstration, we use the same method as above. So I just multiply it by 10, which is then 3.333 and so on. And we subtract these two equations. So we have 9x is equal just 3, and we can find x is 3 divided by 9, which is 1 by 3. So most of you know this result, that 1 divided by 3 is 0.333, and it never stops. So what have we learned here? That a periodic decimal number, so when the digits are repeated, it is a rational number, Q, part of Q. For sure, there are non-periodic decimal numbers, and they are not rational numbers, so they are elements of the real set without the rational numbers. So, and what do you know? In this case, there are actually even more. For example, square root of 2, square root of 3, in general, the square root of a prime number, or the numbers pi, or the Euler number e. So there are infinitely many irrational numbers, square root of prime numbers, yeah? And mathematicians actually could show that the cardinality of this set is more than the Q. So there are more irrational numbers than rational numbers. But if you are interested on this, read articles about number theory. Thank you for your attention, and see you in the next video.